Okay, let's relook at this question. So here we are given a question which says, between which two integers does the square root of 48 lie? So the square root of 48, first and foremost, this is a irrational number. Okay, it's an irrational number. So what we need to then consider about this irrational number, if we were to take this number and put it in the calculator, I'm sure we would get an answer of what number that is. All right, but now we want to find out between which two consecutive integers does this square root of 48 lie between. Okay, so what we do is we think about two perfect squares, one that is immediately after the number 48. Let's just forget about the square root for now. Let's think about the 48. What is a perfect square that you know that is immediately after 48? Yes, you're correct. It's 49. Okay. And then what is the perfect square number that is immediately before 48? All right. Yes, you're right. It is 36. Okay. Those are the perfect square numbers that are immediately after 48 and before 48. So we have 36, which we know if we find the square root of 36, we get 6. We find the square root of 49, we get 7. Right? Now, of course, we can put the square root because 48 is under the square root. So 36 and 49 are perfect square numbers. What is a perfect square number? A perfect square number is a number that is formed by multiplying a natural number by itself. Now, natural numbers 1, 2, 3, 4, 5. So 1 times 1 would give us 1. 2 times 2 would give us 4. 3 times 3 would give us 9. So all of these numbers that are formed are called perfect square numbers, and they are formed by multiplying a particular natural number by itself. Okay. So then we know that the square root of 48 is greater than the square root of 36, but it is less than the square root of 49. So if you read it from, the square root of 48 is greater than the square root of 36, but less than the square root of 49. Okay, so in other words, the square root of 49 is between 36 and square root of 36 and the square root of 49. So then I'm sure you guys can see that therefore the square root of 48 lies between. Now, consecutive numbers are numbers that follow each other. Consecutive integers. So 6 and 7 are integers. 6, right, is before 7, and 7 is followed. Or let me say 6 is before the number 7. And after the number 6, we have 7 that follows immediately after 6. Okay, so that's very important to note. So the square root of 48 lies between 6 and 7. So hopefully you guys get the principle behind answering these questions. Lastly, let's look at this question. It says, write 0.73 in the form of a over b, where a and b are integers. Show all your workings. Now, this is a very important. Show all your workings. Okay. So you write 0.73, and you can see, guys, that the dot, all right, which stands for repeat. So who are we repeating? Just 3 alone. So that means 0.7 3 3 3 3 3 3 3 3, and we could go on forever, right? So the repetition is that of 3. Okay, now what we do is we let x be equal to that, and we say that's equation 1. Now we can actually multiply this decimal by 10 to form another equation. All right, so you know what we do on the left hand side. If we multiply this by 10, it means we move the decimal 1 to the left. So we have 7,33333 if we multiply by what? By 10x. All right, now we can go a step further and multiply that by 100, which means we move the decimal how many times? 2 times to the right. So that's 1, 2. That gives us 73,33333. All right. Okay. Remember, what did we multiply x by? By 100. I mean, we could check if we multiplied by 1,000. Okay. We do the same thing. It means we move the decimal how many times this time round? It means we would move it 3 times. 1, 2, 3. So that means we would have 733, 3, 3, 3, 3, 3, 3, 3, and so it goes indefinitely. Now the objective of doing all of these is to actually we want to be able to then take two of these equations where after the decimal the numbers are the same. After the decimal the numbers are the same. So we're going to look for two equations here where after the decimals the numbers are the same. Now if we look at the first two, these first two will not help me in any way because after the comma you see that 7 3. After this comma there's 3 3 3. So the decimals are not exactly the same. But look at equation 2 and equation 3. If you were to take those two equations together, what you notice is that after this comma the numbers are the same. After this comma the numbers are the same. So equation 2 and equation 3, we take the equation 3 and subtract equation 2. Okay, so that means equation 3, 100x, we are going to subtract with a negative 10x. Okay, on the left hand side. Then on the right hand side, guys, if we take 73 and we minus 73,333 minus 7,333, remember all the decimals will disappear because 3 minus 3 is 0, 3 minus 3 is 0. I'm going to be basically not having any decimals. The decimals will be 0. What I need to focus on is 73 minus 7. Okay, now that tells you why it's so important for me to choose two equations where after the comma the decimals are the same, because the whole objective of doing this is so that on the right hand side I actually get an integer value. I don't want to, like for instance, had I chosen equation 1 and equation 2, the decimals after after the comma for both equations are not the same. This would have still left me with a decimal number after subtraction. But if I take these two equations, they work out. Let's say I had decided to take equation 4 and equation 3. Could I take equation 4 and equation 3? Well, the question is, after the comma, are the decimals the same? Yes, they are. Yes, they are. So I could have taken these two equations, equation 4 minus equation 3, subtract, and then I would still have been able to get the integer value on my right hand side. So since I've taken equation 3 and equation 2, let's go ahead. What's 73, 333 minus 7? We know that the 333's will cancel, but what's 73 minus 7, guys? So here firstly we have 90x, which is equal to, now this 73 minus 7, that gives me what? That gives me 66. Alright, yeah. And then after that, what do? I divide both sides by 90. Okay, and then what do I do after that? I divide by what? I divide by 3. That will be x is equal to, I divide by 3, divide by 3. That gives me 22, divide by 3. So that means there's even a bigger number. So what's nice, guys, is that if you put this into your calculator, you should be able to get a nice... So I didn't want to really waste my time because I wanted to use, my head, but then let's quickly use the calculator and just simply say 66 divided by 90. The calculator, we will get the answer straightforward. Okay, 11, 15. So the answer x is equal to 11 over 15. Okay, so that hopefully helps, guys. All right, how we are able to write our 0.73 there in fraction form, because this is the form that they wanted, a over b. So we have 11 over 15, which is basically how we can express 0.7 with a 3 repetition.